Hey, Calc students. So we are in the middle of a blizzard, so I figured why not make our lesson 6 just in case we fall behind. That way you can watch it. We're going to go really quickly through it in class. So I want to make sure you have a whole second way of viewing this. So how to find the total area analytically? We want to find the area between the graph of f of x and the x-axis over the interval a to b analytically. So let's take a look at this one. We have 9 minus x squared. What we notice is that 9 minus x squared, I've already thrown a graph here for you. We have some positive area right here. We also have anything bounded between the graph here would be negative area. It's kind of hard to see because I didn't stretch this out, but if I want to go from right here, let's say -3 to -5, all of this area would be bounded between the graph and the x-axis, and that's all negative. So we want to partition it from a to b with zeros of f. We want to find out where those zeros are, integrate f over each subinterval, and then add the absolute values of the intervals. So let's take this first one here. So I'm going to take 9 minus x squared and find out where those zeros occur. So negative x squared equals -9. X squared is 9. X equals plus or minus 3 after taking the square root and absolute value. Those are the locations where we have zeros. We clearly see them here. So what we're doing is we're going to find the area right here. Whatever that is negative. We're going to force it to be an absolute value. And we also are going to find this area right here. That will be the absolute value, but it will be positive anyway. So we're going to find the integral from 0 to 3 of 0 to 3 of 9 minus x squared dx. The absolute value of this, and we're going to add it to the absolute value from 3 to 4 of 9 minus x squared dx. You can just account for the absolute values later on. That's going to be the total value from 0 to 4 of 9 minus x squared dx. Now we can do this in our calculator, but I'm going to do this one by hand so you can see, because you're going to have to, you might be in a situation where you have to do it by hand. So 9 minus, we're going to do, this is 9x minus x cubed over 3, 0 to 3. And we're going to add to that the same thing, but 3 to 4. So when we found the antiderivative, we get 9 times 3 minus 3 cubed over 3. Take away 0. Don't even waste your energy calculating that one. I got 9 times 4 minus 4 cubed over 3. This one we do have to account for with our 3's. All right, 27 thirds is 9. This is going to be 36 minus 64 thirds. Take away, I already did the math here, 27 and 9, so I'll just simplify that to 18. Um, 18 plus, and I mean, that's the absolute value, but that's going to be positive anyway. You want to make sure we absolute value after we've done all of the addition and subtraction on the inside here. So this is going to be 18, 36 minus 18 is 18. Take away 64 thirds, that's 21 and a third. Just doing that quickly in my head there, 18, 19, 20, 21. So we're 3 and a third. So it's 18 plus 3 and a third because this becomes positive. So we're at 21 and a third. So the integral, the absolute value of the integral, if you did it in your calculator, if you went from 0 to 4 and you put the absolute value of 9 minus x squared dx, you would have actually gotten 21 and a third for a solution. If you didn't use the absolute value, it would have been 18 take away 3 and a third, and it would have been what, 14 and 2/3. So by not placing that absolute value there, what it does is the calculator thinks about it differently. It will think about it as all being above the x-axis. So it forces that to be positive area in the calculator. It flips everything that's down here over the x-axis when it calculates it. Okay, so right here, we're going to get into some velocity problems. What we do know is that velocity, the absolute value of velocity is speed. We're not dealing with the absolute value of velocity. We are dealing with the absolute value of the integral here. So the integral, if we integrate velocity, we are left with displacement. All right, so the accumulation of area under the curve between that and the x-axis will be your displacement. All right, and the integral, the absolute value of velocity, we integrate the absolute value of it, it's total distance. So total distance traveled. We're going to take all our positives and negatives and put them together. Don't forget that the integral of rate of change, oops, a little glitchy today, huh? The integral of rate of change is equal to net change. So we have to make sure that we do the absolute value of velocity to get the total change. All right, so particle's velocity is given by v of t equals t cubed minus 2t squared plus 1. We want to know the position of the particle after 3 seconds. Given that the initial position of this, that the initial position here is x of 0 equals 5. So what we want to do is we want to do the position of 5, because we're finding our new position. We are going to add to it the integral. Here we're going from 0, so that's going to be the start of my integral. We're going to go to 3 because that's my end of my integral of velocity, which I can just write the equation. So t cubed minus 2t squared plus 1 dt. And if you're wondering, like, where did I get these bounds again? 0 and 3 came from x of 0 and x of 3. All right, so we're going to do the integral of t to the 4th over 4 minus, this is going to be 2t cubed over 3 plus t. And we're going to evaluate from 0 to 3. Well, 0 is nice, that's going to go away. It's just going to be 5 plus 3 to the 4th over 4 minus 2 times 3 cubed over 3 plus 3. And then it's going to be minus 0. We don't need to worry about any of those values. 3 times 3, 9. That's 81 fourths. One of these 3's is going to go away. So 9 minus 18 plus 3. 5, 8 minus, we get negative 10 plus, that's what, 20.25. So it's 10.25, or we can say 41 fourths. We want to leave it in a perfect fraction right there. Alrighty, we're going to retry this one because it was a little bit, some of the math was wrong on it. So start at negative 2, and we're going to add to it the integral from 1 to 2 of t cubed minus 2t squared plus 1 dt. I'm going to ignore, no, I'll keep the negative 2. What am I doing? 2t cubed over 3 plus t. This is all from 1 to 2. Let's see. Again, this is net change, so we're not looking for total accumulation. We're looking for the net. So 2 times 2 is 4, times 2 is 8, 2 is 16, that's 4. Then we get minus 16 thirds plus 2. Take away, and it's going to be 1/4 minus 2 thirds plus 1. We're going to get 4, take away 16 thirds. We'll take away 1/4. We'll add 2 thirds. We'll take away a 1. 4 minus 1 is 3. We get plus 14 thirds. Oh, sorry, minus 14 thirds. And also take away a 1/4. If we put this into twelfths, we get 36 twelfths times 4. That's 40, 56 twelfths. And take away Yep, and then take away 3 twelfths. So just got my calculator here. 36 minus 56 minus 3. Oops. Is negative 23 twelfths. What is the total distance traveled by a particle during the first 4 seconds? Here we're going to, again, break this apart. We want to know the area between the curve. So when does negative 2t plus 3 equal 0? Negative 2t equals negative 3. T is at 3/2. 3/2 is the breaking point here. So we're going to find the integral from, we want to know total distance traveled by the particle during the first 4 seconds. So we're going from 0 to 3/2 of negative 2t plus 3 dt. And we'll add to it 3/2 to 4 of negative 2t plus 3 dt. And we're going to do this one by hand here. So we could use geometry to find what that is. We're going to get, in this case, it's a 1.5 by 3, and half of that. So it's 1.5 by 1.5, which is 2.25 area-wise. This one is what? 5 by 1, 2.5. So half of that is 2.5 by 2.5. That's 6.25, 678. Should get 8.5 or so. Yeah, 8.5. But let's do this one by hand. So we have negative 2t squared over 2 plus 3t from 0 to 3 halves plus negative, you know what? Let's just keep this more simple. We'll call it negative t squared after we simplify it. So we have negative t squared plus 3t from 3 halves to 4. All right, 3 halves squared, negative version. It's going to be positive 9 halves. Take away 0. It's not going to matter. Here we get negative 16 plus 12. Take away whatever I get here again is negative 3 halves squared plus 9 halves. All right, we get negative 9 fourths plus 9 halves. Come on, 9 halves. Negative 16 plus 12 is negative 4. And then we got a double negative here, so we're going to add 9 halves to it. Oh, sorry, add 9 fourths. And then take away 9 halves. But we want to make sure, that whatever value this is the absolute value. In this case, we are going to add the absolute value of these items when combined. So negative 4 plus the 9 fourths minus the 9 halves. All right, we're running out of room here. Let's bring this over. Negative 9 fourths plus 18 fourths is 9 fourths. That is our 2 1/4 right there in that spot. So that value is working out great for us. And we're going to add to it. Let's see what we get for this one. We get, and we're going to put everything in terms of fourths. So negative 16 fourths plus 9 fourths minus 18 fourths. That is 9 minus 18 is negative 9. And then negative 16 is negative 25 fourths. Negative 25 fourths. That is 6 times 4 is 24. And then 25 is our last one. So that it does work out to our negative 6 1/4. We are performing the absolute value operation to everything. So we get 9 fourths plus 25 fourths, which is 34 fourths or 8.5. Boom. All right. Next one here, we have if H, this is kind of the same setup. If H, capital H, is negative pi, of negative pi is 12, and H prime of t equals cosine of t, what is H of 3 pi over 2. So we want to know the accumulation from negative pi to 3 pi over 2 of the cosine function. And we want to, and this is fundamental theorem of calculus, right? So we are starting at 12, and we're going to add to it the setup here, because that's your 12, your starting place, your ending place, everything's all right here. So we're going to do 12 plus the antiderivative of cosine is sine. It's going to be sine of t from negative pi to 3 pi over 2. Oh, this is quick. We're going to do sine of 3 pi over 2, take away sine of negative pi. 3 pi over 2. Sine of 3 pi over 2 is pi, it's negative 1. And then here we have minus 0. So our end result is 11. Now, if it said find total total area, we would have to be careful here. We would have to find the absolute value of it. So, yeah, because sine is, let's see, sine goes, here's our 3 pi over 2. It's negative 1 is our output here. At 3 pi over 2. Now, yeah, so what is h of 3 pi over 2? We're all good with this. This was not looking for total distance. It was just looking for what is h of 3 pi over 2. So we have to account for the negative area. Okay, we're at a FRQ, an example of an FRQ. I think this comes from one of the more recent exams. Let f be a differentiable function. F of 4 equals 3. That's important information. Whenever we're trying to find f of 0 and f of 5, we have a starting place at 4. So we can go back to 0 or forward to 5. On the interval 0 to 7, here's the graph. So what we know is that we are given the graph of f prime here. The derivative of f consists of a semicircle and 2 line segments shown in the figure above. So if I want to use a fundamental theorem of calculus. So if I'm given the function that is going to be equal to f, let's see, if I want to find f of 0, let's go from 0 to 4. That's going to be f of 4 minus f of 0. So the antiderivative of the function the antiderivative of the derivative of the function f of 4 minus f of 0. So what accumulation happened from 0 to 4? 0 to 4, this accumulation here, our accumulation is, area is 1/2 pi r squared, but it's also in the negative quadrant. So it's going to be area is negative 1/2 pi, my radius is 2. The area here is negative 2 times 2 is 4, half of that's 2. Area is negative 2 pi. Negative 2 pi gets replaced in for the accumulation from 0 to 4. F of 4 was given to me. It's a value of 3. And so negative 2 pi minus 3 equals negative f of 0. That's a quick fix. Multiply everything by negative 1. We get that f of 0 is 2 pi over 3. I'm going to do the same thing for f of 5. So I'm going to go from 4 to 5 because it gave me 4. The accumulation from 4 to 5 Can hear snow falling outside still. All right, this is area's 1/2. It's a 1 by 1, but it's half of that, so half. So the accumulation from 4 to 5 is a half. F of 5 is unknown. F of 4 is 3. Move that over, we get 3.5. All right. Next question. Find x coordinates. Find the x coordinates of all points of inflection of the graph of f. Okay. So a point of inflection occurs where f double prime of x changes sign. It's when the rate of change is starting to change. So we have to make sure we were given f prime, not f double prime, so we can't use f double prime in this scenario. So f double prime, what does it represent? It is the slope of the graph of f prime. That's important. You have to make that connection that the f double prime is the slope of the graph of f prime. So therefore, a point of inflection is where the slope of the graph of f prime, look how specific I'm being here, changes from positive to negative. Oh, come on. Positive to negative, or vice versa. So negative to positive. That's what we're looking for. We're looking for when the graph of f prime changes from negative to positive or positive to negative. Where does that happen? Well, from here, we have a slope that's negative and then positive and then negative. So the two locations are at x equals 2 and x equals 6. So we can state the points of inflection of function f occur at x equals 2 and x equals 6, because this is where the slope, look at what I'm saying here. I'm saying f prime. I'm being very specific. I'm not just saying it or the or graph. So where the slope of the graph of f prime changes from positive to negative. Um, I could say from negative to, let me put it in order. So negative, from negative to positive and positive to negative, respectively. Okay, I think it's spelled respectively. It doesn't matter. I don't know. ELY. Perfect. All right, let g be a function defined by g of x. On what intervals, if any, is g decreasing for that? Okay, g of it. Well, if we want to know what intervals is g decreasing, so they introduced that the function take away x is equivalent to g. So that means that g prime is also equivalent to f prime take away 1. Because we don't have f. We have f prime here in our graph. So let g be a function defined by that on the intervals if any is g decreasing for 0 to 7. Show the analysis that leads you. Okay, so we want to know the intervals if any where g is decreasing. So that's where the slope of f is going to be negative. So if g prime is less than 0 or equal to 0, we can just say less than or equal to 0, then that is where it implies that g is decreasing. G is decreasing. So the same statement can be made for f prime of x minus 1. That would be where g is decreasing. So f prime being less than 1 implies g is decreasing. That's interesting. So the derivative, when the derivative has a result of 1 or less, is when g is decreasing. Okay, that's going on right here. So we can see that where f exists below, where f, below 1 is where the g of x will be decreasing. So that happens from 0 to 5. So we're going to state we'll say that g is decreasing where f prime of x is less than 1 on the interval zero less than or equal to x less than, I'll be consistent, less than or equal to 5. It doesn't matter if it's included or not, because g prime of x is less than or equal to 0 on this interval. I'm actually kind of stating too much here, because I already stated f prime is less than 1. All right. For the function g, we're at our last part here. It's defined in part C. Find the absolute minimum value. So the absolute minimum value can occur anywhere from 0 to 7. Well, think about it realistically. If the function g is decreasing all in here, all the way up to 5, and then all of a sudden at 5, because above the line 1 for f prime, it's then increasing. If that's happening, 5 is going to have to be my least value, my most absolute minimum value. You can't just say that, though. We have to use calculus techniques to do that. So I would suggest that we use a candidates test, that we test any critical point, 5, and 7. Well, see these critical points here, 5 and technically 7 is a critical point because it's where the number 1's happening, but it's also an endpoint. So we're going to test endpoints and critical points. So we're going to find f of 0, f of 5, f of 7, 0, 5, and 7. I'm just going to list this information out for the reader. I'm going to say critical points are x equals 5 and x equals 7. That's where it would cross or intercept the axis. Well, it's not really, we could leave this off as a critical point. It's not crossing the axis. Let me just leave it off. We're going to test endpoints anyway, which is going to be the 7. So let's just say it's an endpoint x equals 0 and x equals 7. Furthermore, we know the absolute minimum g prime of x is less than 0 for, for 0 less than x less than 5. So that's enough information for us to know that there would be, um, oops, and g is greater than 0 for 5 to 7. So we know that 0 and 5 are anywhere in between there would be our possibilities. Seeing as it was accumulating negatively all the way up until 5, it would be it. But we're just gonna go and do the candidates test to find these. So first I'm gonna do, we know g of 5 is equal to f of 5 minus, let me reintroduce my equation. So g of x is equal to f of x minus x. It's the original equation they gave me. So g of 5 is equal to f of 5. Oh, we're getting glitchy. Is equal to f of 5 minus 5. So g of 5 is equal to f of 5 we found. That is 3.5. G of 5 is negative 1.5, or negative 1.5. We are going to just do this again. We're going to do g of, let's see, g of 0 now. So g of 0 is f of 0 minus 0. And f of 0 we found to be 2 pi plus 3. 2 pi plus 3 minus 0. So that is clearly one of our higher points that we're doing. 2 pi plus 3 over the course of the 2 pi gets you back to your original 3. That's what we're looking for. Keep going all the way to 5 gets you negative 1.5, as you see there. Lastly, I don't have f of 7, so I'm going to have to work on finding f of 7. So I need to do a third one here. I'm going to go from 4 to 7 of f prime. So the accumulation from 4 to 7. 4 to 7, I'm going to break it into a trapezoid, and that's, let's see, 1.5. And here, that triangle is 2 by 2, is 4, half of that's 2. So we're looking at accumulation of 3.5 total from 4 to 7 is 3.5. So 3.5 is equal to f of 7, take away 3. That's my f of 4. So f of 7 has to be a half. Just for the heck of it, I'll copy this. I'll bring it down here for us. So that information would be needed. So I'm going to say g of 7 equals f of 7 minus 7. G of 7 is equal to 0.5 take away. I messed something up here. Oh, my bad. If you add 3 to both sides, you get 6.5. Oof. I was like, that doesn't work. That would be a minimum. Here we have 6.5. Take away 7. Clearly it's not enough. We get -1/2. So we can finally conclude we have an absolute minimum of -1.5 at x equals 5. Boom, there we are. So that's it. You notice that wasn't too bad. All right. We will go over this lesson and lesson 5 in class. Good luck cleaning up from the snow.